Okay. We say the role of this YouTube channel. Yesterday I was there in Ramogi TV, like everyone is calling me. I want you to follow my YouTube channel. It's called Gaddafi, Mr. Gaddafi, Mamu High School Chemistry Guru. That is my YouTube channel. You go there, you go to the comment section and say, write what you want to be taught, so that I take the video and post. Now, I want to talk about a certain concept. We say my YouTube channel is not here to explain what is already in the textbook. It is here to explain concepts that are in the textbook and have not been given scientific meaning. Today I want to talk about organic chemistry test. Now, the reagents that we normally use, the one that I want to talk about are this one. One is acidified potassium manganate 7. This hydrogen stands for acidification. Acidified potassium dichromate 6. Now this substance is purple and this one is orange. Is acidified also. Now the acidification is simply why if a student asks why do they have to be acidified? If you want a potassium dichromate 6 to exist in this form, then you acidify it. If there is no acid, it simply changes to potassium chromate 6, which is yellow. This is the oxidizing agent that we're looking for. So if you don't acidify it, it will revert to this. This is yellow. Potassium chromate 6, sorry. This is potassium chromate 6 and this is potassium dichromate 6. So acidification is to make it to be in form of potassium dichromate 6, which is the oxidizing agent you're looking for. But if you don't acidify it, it will revert back to potassium chromate 6. So both of them will have chromate 6 ion, but this is the oxidizing agent. This one also, if you do not acidify it, it will change. It normally decomposes at room temperature to generate manganese oxide, water, and some other substances. So that's why you need to acidify it, because you need potassium manganate 7. So we want now to go to the chemical test. Where do we use these reagents in organic chemistry to do a chemical test? Now, in organic chemistry, tunaambiwanga ukiweka acidified potassium dichromate 6, ukiambiwa uweke na uone pale imechange to green, you write ROH present. Na ukiweka potassium manganate 7 na uone the purple color changes to colorless, you write triple bond or double bond, triple bond, and ROH. But these people are not explaining for us. Why am I so if the orange color of acidified potassium dichromate 6 remain orange, you write ROH absent. But these people are not giving us the scientific meaning. And that's what I want to give today. Now, there's a scientific meaning for every concept that's being taught. But in the textbook, these scientific meanings are not given. I want to explain for you something. Now, I want to use two examples of two compounds. Let me say this one is a compound with carbon-carbon double bond. Let's take a liquid. 1, 2, 3, 4, 5. This is pentene. 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 And now to take another one. This is pentane. This is also liquid. 1, 2, 3, 4, 5. So the OH is here. Hydrogen, 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 hydrogen. So these are two organic compounds. So this one is pentan 1 all, pentan 1 all, I'm a pentanol. And this one is pent 1 in or 20. Now if I add dichromate to this, the color will change immediately from orange to green. If I add dichromate to this and I do some small warming, it will change color immediately from orange to green. But if I add dichromate to this and heat, the color will not change immediately from orange to green. The color of dichromate will not change. But if you put it for some time, uchukue dichromate uweke kwa hii na uipatie muda, maybe like 7 minutes after heating, you will find the colors change from orange to green. Now, so I want to give you the reason why dichromate is regarded that it doesn't change color with a double bond or triple bond. Scientifically, that is wrong. It can simply change color. The reason why it is not accepted by NEC is because of this. Mwanafunzi anaambiwa add and observe. Lakini wewe, so when you add and observe, so you add acidified potassium dichromate, warm kidogo na observe. If it is alcohol, it will change color immediately. But if it is a compound with double bond or triple bond, it will not change color immediately. So utaweka pale kwa testing rack. Ukirudi baada ya dakika 7 utaona color may change to green. So dichromate can simply change color with this. But it is not an instant process. Haifanyiki immediately. Na KCC unaambiwa add and observe. So when you add and observe and the color changes from orange to green, immediately then it is ROH present. But if you add and warm and put it for some time, you'll see the orange color changing to green. But permanganate can change color with this one or this one at room temperature. Permanganate can do that. Reason is this. Why is permanganate being able to change color with double bond and triple bond, and also change color with ROH, while dichromate can only change color immediately with ROH? Let me explain this. The double bond is in between atoms, so this double bond is already electrons. The double bond is in between atoms. It's surrounded by many atoms, so there's electron cloud that is repelling approaching atoms. So there's electron cloud here. There's electron cloud. Why is it the electron cloud? The electron cloud are present because the double bond and triple bond are between atoms. These are 4 electrons, these are 2 electrons, these are 2 electrons, these are 2 electrons, these are... So the double bond and triple bond are in between atoms, and there is a lot of electron repulsion due to the high number of electrons that is repelling. So that repel any atom that is approaching. So permanganate, being a strong oxidizing agent, it is able to overcome that electron cloud and react with alkenes or alkynes. Dichromate, that is a weaker oxidizing agent as compared to potassium dichromate, potassium manganate 7. So due to the high electron cloud, dichromate cannot overcome the electron cloud that are repelling the approaching atoms. So that's why dichromate is regarded that it doesn't change color with alkenes, but it simply changes with alkynes also. It simply changes. But the change will take time. But pale kwa exam kwa KCSE utaambiwa add and observe. So when you put dichromate hapa, the orange color will remain orange. But if I put it here, the orange color will change to green. This is because of this. In OH, the functional group is outside. It's not like double bond ambayo iko between atoms. So there's electron cloud ambayo ina repel atoms. The OH functional group is outside and it is not surrounded by many atoms. So there's less electron cloud. like the double bond and triple bond are in between atoms and there's a lot of electron cloud. So the dichromate will change color immediately with alcohol because the OH functional group is outside and is surrounded by fewer atoms. Hence there's less electron cloud. It's not between carbon atoms, it is outside. And that's why teachers should also tell us that dichromate will also change color with alkanols, which are simply primary. What is a primary alcohol? A primary alcohol is an alcohol where the OH is attached to a carbon attached to another one carbon. But if I was to remove this OH, replace a niende hapo, this dichromate will also take time because this will be in between atoms and this will be electron cloud, preventing the atoms from accessing OH. And in high school, we only talk about primary alcohol where the OH is outside. So dichromate doesn't change color with this. Don't say it doesn't. It simply changes. But the different in cases unaambiwa uweke na uangalie saa hiyo hiyo. Saa hiyo hiyo haitachange. So you write ROH absent. But if you give it time, and that's why I normally tell my student, ukiadd dichromate, uangalie saa hiyo hiyo. Don't walk until where you're doing it. Unatoka kwa reagents, mahali umeweka reagents, una walk unaenda pale mahali unafanya practical. Ukifika pale ukiweka unaona the orange color start to change green, and then you write wrong observation and wrong inference. So I've already explained that you should never put dichromate and work with it. Put and observe immediately. If it changes color, it is an alcohol, ROH present. But if there's double bond and triple bond, it will not change color immediately, but simply it will change. Dichromate will change color with double bond and triple bond. But the KCSE exam that tunaletewa tunaambiwa add and observe. So dichromate will take a lot of time for its color to change with double bond and triple bond. Usiwahi enda umepata scholarship umeenda US, alafu naambia watu at dichromate doesn't change color with alkenes and alkynes. It simply changes. The only reason is there is electron cloud. Why? The double bond and the triple bond are in between atoms, surrounded with other atoms. There are so many electrons, so there's electron repulsion. So there's electron cloud that is repelling atoms that are approaching. So it requires strong oxidizing agent like potassium manganate 7 to be able to overcome that. But dichromate will change color with the alcohol, especially the primary alcohol immediately. This the OH functional group is outside and it is not surrounded by many atoms. So there's less electron cloud. Since dichromate is a weak oxidizing agent, so it is not able to overcome this electron cloud that is in between double bond and triple immediately. But a manganate will do that. A manganate will change color with the double bond, triple bond, and ROH. But dichromate will change color immediately with ROH because the OH is outside. There's less electron cloud. The double bond and the triple bond are in between atoms, and that requires very strong oxidizing agent to overcome that electron repulsion. So the double bond and triple bond are between atoms that, because of that, there are so many electrons that are causing electron cloud that prevent any approaching atoms. But permanganate can overcome that because it's a strong oxidizing agent. Dichromate is not able to overcome that immediately, but if you give it time, it will change color. So tafadhali walimu tuambie watu wa NEC and the people are misleading people, because the real science is this. What I've explained, that's the real science. The dichromate can change color with double bond and triple bond, but it will take time. But you are told add and observe. So unaweka na unaangalia saa hiyo. So if it is ROH, it will change immediately. If it is double bond triple bond, ukiweka utaona orange color remains orange. Alafu unatembea nayo pale mahali unafanya practical, unaweka pale kwa test bracket, unafanya vitu zingine, ukirudi unapata kale imechange green. Unaanza kusema. So when you put dichromate, hakikisha umeangalia saa hiyo. But permanganate will change color with double bond and triple bond. Why? It is able to overcome the electron cloud. Dichromate will not do it immediately. but it will do it immediately with the ROH. And that's why when I'm told add dichromate, you observe immediately. If the orange color changes to green, ROH present. But you should not add dichromate ukose kuobserve immediately, uende uweke pale. Hata kama hiyo compound haina, is not an alcohol but has double bond and triple bond, utaona color yake ikichange. So dichromate can simply change color with double bond and triple bond, but it doesn't happen immediately. It takes time. But an alcohol, it does it immediately. So we shall explain more chemistry that is not being explained in the textbook. Why students are being told dichromate yako naika to ROH present or ROH absent. It is well explained that the double bond, triple bond are in between atoms. There's a lot of electron cloud that requires strong oxidizing agent, but the OH is outside, so dichromate can change color with it immediately. So next time you're told to add dichromate, add and observe. Don't add and walk with it. If it changes color there and there, ROH present. If the orange color doesn't change, ROH absent. But if you walk with it and go there, it will change color. Thank you. 20.